All right, good morning, everyone. All right, let's try that again. Good morning, everyone. All right, I know you all traveled from parts afar, and thanks for joining us first thing here in the morning at Astracon and for spending a few minutes learning about Stir and Shaken and the Stir and Shaken framework. I'm curious, has anyone here in the room implemented Stir Shaken yet? Good. Anyone want to learn how to implement it? Hopefully a few of you. All right, good, you're in the right spot. All right, so let's dig in for a second. I'll do introductions in just 1 second. So robocall fraud, it's more than annoying. What we're seeing now situations where by falsifying caller ID, individuals are starting to see telephone calls, for example, like this situation here, an 800 number that says it's from the IRS, and an announcement says, this is the Internal Revenue Service calling about an issue with a recent payment. Please hold the line, and then they're connected with an agent. And the agent tells this individual that they've somehow something happened with their tax check and they need to wire money immediately, go to Western Union to use an Apple Pay card, whatever it might be, to send money. And of course, this is a scam. This is entirely a scam. The IRS does not call you, but unfortunately, people fall for this. And according to the Treasury Inspector General in the States, over 10,000 victims have paid over $54 million in phone scams since by October 2013. Now, that was 5 years ago. Imagine what it's like now. It's probably a much, much higher number now. So this is a real serious problem. So I got together with Jim Dalton, and we put together a webinar that we delivered a couple of months ago to create some content to introduce the Stir, Shaken framework. Jim wished he could have been here today. Unfortunately, he had another event he had to step off to, and so I'm running this show here solo. But a lot of the content comes from Jim, so I'm going to give him a shout out for that. So I'm Alan Percy. I'm the Senior Director of Product Marketing at Telco Bridges, and pleased to be here and glad to see you. Oh, you folks are here ready to learn about the Stir Shaken. So, all right, what are we going to talk about today? One of them is we're just going to spend a couple more minutes talking about the problem, and once you understand the problem, you kind of understand why the solution has been put together the way it is. You know, what's the impact, certainly, of fraud from a financial and also from the service providers from a business standpoint. And we'll talk about how it's impacting wireline and VoIP providers. Some of the regulatory actions that have been taken and standards that have been set. Then we'll spend probably about half the session talking about Stir and Shaken and the framework and how it works and how to implement it. And then we'll wrap up with your Q&A and any other discussion you'd like to have on the topic. So let's move on. So what is the problem? Well, what we're seeing, as a result of fake caller IDs is the New York Times reported in May 2018 that 3.5 billion unwanted robocalls by April of 2018, just in April for that month. 3.5 billion. Now, how many of you, of course, everyone's had robocalls, and you notice the caller ID, right? It seems to be a pervasive problem, and a couple of slides we'll talk about where they're coming from and why they're so hard to squash. Another thing is some of the do not call lists, right? Remember a few years ago, everybody was told go to sign up for this do not call, and then there was a push to for people to do it with their cell phones, which was unnecessary, but we had to all go on and register on the government website, the do not call site. Well, they don't, the bad guys don't pay attention to those. They don't use those lists, and unfortunately, go right past. And one of the last little tricks is this neighbor spoofing, right? The number looks close to your number, your mobile number, or your home number, if you still have one. Where the number looks close, you think, oh, it might be a neighbor or a friend or whatever it is. It's not in my directory, so I'll answer the call, and sure enough, it's a robocall. And also, too, there are some crowdsource-based blacklist platforms, and this is what some of the service providers have been using to try to stem the problem, is if there's a number that repeatedly does robocalls, that they put them on a blacklist, and unfortunately those blacklists not only are catching some, the bad guys, but they're catching some of the good guys, and there's some negative impact on that too. Unfortunately, like for example, I know my home number was used as a spoof, so I had people calling me back all the time saying, oh, I missed a call from you. And I was like, no, I didn't call you, Unfortunately, and I got a bunch of those, and I have a sneaking suspicion, probably my home number's on a blacklist now. So what happens here? This is the situation today. A robocaller, signs up with an originating service provider anywhere in the world, and of course they make telephone calls with a fake caller ID, so that you don't really know the origin of the number. That number then is transferred from the originating service provider to the terminating service provider. It might be your Verizon or your Bell South or whoever your service provider is. And of course, you end up with these calls and you're an unhappy caller. But unfortunately, usually most consumers blame their service provider for the problem. They don't blame the originating service provider or the originator of the robocall. They blame their own service provider. Why do you let these calls through, right? And they're very unhappy, and it has some impact. And the last thing is the origin of those robocallers. A lot of them, a huge amount of them, are coming from this new platforms called CPaaS. Anyone been working with a CPaaS platform yet? It's basically a HTML-like scripting language environment where you can develop IVR applications and generate thousands of outbound calls with fake caller ID. And it's very easy to do. You can get free accounts, and within a few minutes, you can set yourself up to start generating robocalls if you wanted to. So the side effect of that, of course, is very unhappy customers. And it's starting to show up in surveys and in market studies that top line, the retail switched access lines, continuing to dwindle. And one of the number one complaints people have about their wireline service, if you're a wireline service provider, is I get nothing but robocalls on my phone line. Why should I keep this phone number? What's hard to explain to them is that, well, very soon, that's all you're going to get on your cell phone too, by the way. It's coming, and it's a wave that's a serious problem. Even the VoIP providers are not seeing the business growth that they thought they were. The mobile operators certainly are benefiting somewhat from it, but it is hurting the wireline operators, and they play a critical element in our public safety and a lot of other assets in our daily lives. So it's a real problem. So how does this happen, right? So as we talked about earlier, a call made by a robocaller, and again, it could be a CPaaS script, which is fairly straightforward to develop, using a SIP trunk with an originating service provider. He drops a call on the network. It shows up to the terminating provider, and of course, he just trusts that that number is correct, and he delivers it to the consumer. The consumer, of course, sees it's from the IRS, so they sees that it's from their bank or whatever it might be. He answers the call, and unfortunately, they can be very easily faked out to deliver information, private information, account numbers, social security numbers. There's all kinds of really tricky scams to get people to fork that information over. So, it's very easy on the dark web to get just enough information that when you give it to somebody, they will give you the rest of it. Right? That's one of the tricks. If I give you just enough information about you, that then you'll be tricked into giving me the rest of it. Now, so we have your mother's maiden name as Smith. What was her first name again, right? That kind of information that they can get away with. So anyway, that's one of the biggest problems. And there's a whole host of them. Would be interesting in each person's individual situation, see how many of them got them, right? So, low interest rates, credit cards, student loans, business loans, the IRS one, which I talked about earlier. This is one I was getting for quite a while, is the search engine. I'm calling from Google, and we wanted to, correct your Google presence. It's like, Google doesn't call people to tell them to change their online presence. You get a message in your Gmail box. Travel discount trips. Oh, you've won a trip. You've won an overnight stay. Pre-approved loans, home security, to utilities. All these, of course, are a problem. And recently, and I just wrote an article this week about a company was caught trying to sell health insurance. They had called 21 million people in a matter of just a few months. The FCC caught them and fined them $82 million for their actions. So there is a little bit of a pushback and a little bit of bite that comes from the FCC, but frankly, most of these are coming from outside the US, and the Federal Communications Commission doesn't have much in the way of any leverage to squash it. One of the last problems, and I sort of hinted to this, is is the problem with good calls being ignored. So you can very easily imagine your neighborhood school would like to notify parents of a school closure or of a weather event or some change in situation at the school, or maybe there's a lockdown at school, to notify the parents that the kids are going to be released early or late. So they try to make a bulk set of calls, and unfortunately people are so used to their landline, or when they see a strange number, they won't answer it. So even though it's a legitimate call, it can arrive at someone's phone, and they look at the number, they go, I don't know a 209 phone number, and they can ignore it. And it was something important. It could be a reminder for your doctor's visit, or something important like that. Or inadvertently, that person's, or that originating enterprise's number gets on one of those blacklists we talked about earlier. And then they get blocked by the service provider. So these are two very common problems that now have just become sort of part of our psyche, right? So, I don't recognize the number, I'm not going to answer it. Hopefully they leave a voicemail and you get the voicemail soon thereafter. So I mentioned here that good calls are being ignored. That we're seeing upwards of 20% decrease in enterprise contact rates, or people just don't answer the phone anymore. And again, sometimes it's for good reasons. Doctor's office, the school, there are valid reasons for people to call. 20% decrease in answer rates for outbound call centers. Contact centers obviously are struggling with trying to reach out to people. And again, there's very legitimate reasons, right? You're late on a payment, your car loan's due, there's a new offer to reduce the cost of some service. And of course, now upwards of 75% of consumers miss important calls. And this is Neustar's been doing a survey trying to understand the impact of the robocall problem. So what are the regulatory bodies doing about it? Well, one of the more aggressive organizations is the Canadian regulator, CRTC, and they put a mandate out to the Canadian service providers, which, as you know, is a smaller community than there is in the States, that by March 2019, they have to implement this stir-shaken. And we'll talk about how does that affect other service providers, right, in a few moments. It's great that the Canadians are doing it, but how does that affect you, maybe if you're in the US or in other parts of the world? And the FCC put together a bill in April called Robocop, requires that telephone companies deliver verified caller ID. They did not necessarily say how that needed to be done, but they stated that. They set that as a goal. And they also, too, the FCC issued a timeline for the Shaken Trust Anchor, and we'll talk about what that is in a moment here. And Verizon announced that they were going to start deploying that. And this is probably the biggest reason why other service providers and enterprises need to be aware of this, because once one of the large service providers requires certificates for the calls that arrive on their network, you'll see the impact directly on calls that you send into the network. Okay, so how is this proposed to be resolved? All right, and basically it boils down to this. If a call comes from a robocaller, goes to an originating service provider, if there's some way to authenticate that caller actually owns that number, all right, if we can just come up with a way, and we'll show you how we're planning on doing it, there's a way to authenticate that they actually own or have the rights to use that number. Then when it goes to the terminating service provider, that terminating service provider can then make a couple choices. They could either deliver the call if it is signed and it is certified as having a proper caller ID, or if it's not trusted, it could deliver the call with a warning, and we'll talk about how they plan on doing that, or it could go to like a phone CAPTCHA, which is, I'm sorry, we don't recognize this telephone number. Please enter a 4-digit code. Please enter the 4-digit code 1234 to proceed to make the call continue. And by just doing that phone CAPTCHA, you know there's a human behind that call as opposed to a bulk caller. Now that has the problem of remember we talked about bulk calls coming from enterprises that do own the number, right? They should be signed, right? They should be able to get through without having to go through a CAPTCHA because they are automated. So basically two solutions. One of them is either send the call to the user, to the recipient with a warning, or to send them to a phone CAPTCHA kind of application for screening. Okay? All right, so how's this going to work? All right, there's a couple things. First of all, some terminology. There's two real technologies, and of course, they're kind of a cute little name, the stir shaken 007 kind of coding. The IETF, ATIS, and the SIPforum all got together and developed a couple of standards that are critical for this. The Secure Telephone Identity Revisited. It's internet-based verification for the calling party's authorization to use a telephone number. Now remember, there's a couple different ways people can end up using a telephone number. One of them, they can actually own the number, it's their number, or they've been given permission to use the number. And you can imagine a school sending out notification calls. The school's not going to own the infrastructure to send the calls, but the school would give their number to somebody to then let them use it in a bulk calling scenario. All right, so a service provider would be given permission to use the school's main telephone number to do bulk calls because they want people to recognize the number and answer the call. Or a business could say, my outbound call center is going to make tens of thousands of calls, so I'm going to give permission to somebody to use that number. So this whole method of giving permission to use the numbers is a critical piece. Okay. The second is this shaken, which is the secure handling of the tokens. And this is basically how to pass a verified token from the originator to the recipient in such a way so that you can verify that the recipient, or at the recipient end, you can verify that the originator had permission. All right, and we'll show how this all works here in a minute. But anyway, the two of them work together, and it's called a framework between the two of them as to how it works. So, all right, so this is what the originator does. This is at the originating service provider. When a call arrives at their core of their network, the first thing they have to do is authenticate that the calling number is either within their domain of known numbers. All right, so that's a caller, subscriber is using their own number to make a call, and then the service provider needs to attach what they call an attestation level. And this is either coded as an A, B, or C. So A, it's a subscriber. I know who they are. They're one of my consumers or users of telephone numbers. I know the phone number. It's one I gave to them. Or B, I know who they are, but it's in a trunk group. And trunk groups create kind of an interesting little problem because there's a lot of different numbers that go with it, and people can potentially abuse it. But in general, usually a trunk group is owned by somebody. Or C, we're not exactly sure who they are, and we're not sure where it came from, so it's kind of a mystery call, so we're going to attach it with a C. So then what happens is you're going to be creating a digitally signed identity token, and I'll show you what those look like in a moment, and then pass that as part of the SIP invite when it goes into the network. So what we're going to do is, essentially, we're going to, as an originating service provider, we're going to look at the number, we're going to look where it came from. Do I know who it is? Do I trust where it came from? Put a token on the front of the SIP header, and then I'm going to drop it into the public network, right? So I'm going to send it on its way with this token attached to it. So now the recipient can know whether or not the originator knows where the call comes from, all right? And this is done with a private public key combination, and you'll see in a moment when they go to verify where that comes from. All right, to create this signature. Any questions so far? So far, so good? Good. I've seen a lot of goods. All right. All right, so now it gets to the terminating service. And remember, it's not always just originating destination. A lot of times calls bounce around the network all over the place until they pop out at the destination service provider. It's not uncommon for 2 or 3 hops in between. Those hops in between, they just pass the call along. A SIP invite shows up, it's got one of these token headers, it just passes it along. It doesn't know anything about it, doesn't care anything about it. It's not their job to verify, it's not their job to authenticate. They just forward the call along. Now it's up to the job of the terminating service provider, which may be a lot of you folks too. They see the call arrives, the SIP header arrives, the invite. They see the call was signed. All right, so that's one big step. Second step is now I'm going to take this token off the header and look at and use the token with the certificate authority. And I'm going to go fetch the signer's public key. I'm going to use the public key then to decrypt and verify that the call, that the signature matches what was passed in the originating call. Right? So I'm passing, much like HTTP, I'm passing the call into the network. I've signed it with an encrypted key. It gets to the far end. The public key is used to decrypt it, and I can see that it's indeed valid. So I know that that was not messed with as it got passed through the network. Okay? And then based on that, I can now open the token, and I now can see whether it can see the information that was inside the token. And we're going to look at what's inside there here in a moment. All right. So of course, this all depends on a lot of the web infrastructure for certificates and certificate authority. And one of the first steps with all this, of course, is having a certificate authority that hands out what we are hoping are short-lived certificates. Meaning, one of the problems with certificates, as you know, is once someone were to get their hands on one, they can abuse it, and so you have to rotate them fairly often, right? So the trick is like changing your password, right? If I change certificates on a fairly often basis, because of this, you're always using the originate calls. You can change certificates fairly often. There needs to be some certificate management service to manage and hold these certificates, and then a repository and a key store. And so this actually makes a lot more sense once you see the call flows. All right. This is where the rubber hits the road. So at the bottom here, calling party is going to make a call, and most likely it's going to hit a session border controller. And the session border controller, what it's going to do is it's going to go is based on the call originating, the calling party. The service provider says, I know who this is. It sends the call up with the attestation we talked about earlier up to an authentication service. And it's going to do is create that SIP header. It's going to go to the key store, pull the key, create the token, and then send the token back down to the session border controller. Session border controller then sends the call out to the public network. And it's really a quick process of sending that. What's evolving in the market, and this is what TransNexus is doing, is they're offering that top bubble, the top box, the key store, and the authentication service. They're offering that as a cloud-based service to their customers. So the idea being is that the infrastructure doesn't need to be built within the core of the service provider's network. They just have to have a session border controller that knows how to send a call over to the authentication service. The service will add the token to the header and send the call back down to the session border controller. Again, this is no media takes place. This is all just SIP headers. Okay, and then the call goes out into the public network. And this is what one of these identity tokens looks like when it's not encrypted. It's got a couple of key things. First of all, it's header identifying as the shaken header. That X5U is where the public certificate is. And then that attestation I was talking about is, in this particular case, is an A, meaning this is a subscriber and I know who it is. The number we're trying to call is this 1469 number. The timestamp, then the originating call number, the caller ID, and then this originating ID is just like kind of a hash code that the service provider can attach to identify that particular call if they need to go back for billing purposes or whatever. So this whole package is attached to the front of the SIP message, and this is actually what it looks like when it's encoded. This is that 64 base code coded. So it's a big glob of text that goes on the front of the SIP header. Okay, so now a SIP invite shows up at the terminated service provider. That's on the bottom here, bottom left. Inbound call, again, a session border controller, usually at a service provider is the first stop. That session border controller needs to go up to the verification service. And again, it could be the same one that was on the originating side, or it could be a different verification service, in-house or a service. He goes to the certificate repository, pulls that certificate, decrypts it, looks at it, verifies it, looks good, sends it back down to the SBC, and then it goes into the switch or the applications within the terminating service provider, and then decides to deliver the call. And that's the last step of the puzzle, which is knowing, okay, let's say I get a call that's not signed, or I get a call that is suspicious, or I get a call that is signed. What do I do with it, right? As a service provider, they have to make a decision on that. Okay, so far so good? Good. All right, so this is where there's been a little bit of a debate on the user experience. On the receiving end, there's many different options as to how a call could be delivered. It's either on a mobile device, could be a landline device, or another mobile, but different ways that this call could be delivered. Either it's trusted, like the number on the right, or on the two left ones are suspicious calls. And actually, there was quite a bit of work done by the SIPforum. I think it's this next one here. Yeah, the ATIS and the SIPforum did quite a bit of work this last year trying to come up with a standard user experience for calls that are both good, likely spam, or suspect calls. And they put together a host of user experiences, put together a focus group, and had them receive calls based on these different methodologies of displaying this information. And based on the results of that focus group, they then came up with a standard specification as to how this information is to be displayed to consumers at the receiving end. And that is outlined by this technical report on a framework for display of verified callers called ATIS, what is it, 100,081, no, 1,000,081. And actually, when we get done with this, if you want to copy this presentation, click on that link and it'll take you right to it. It's on my blog too. Okay, so that's how the information is being displayed. This is an example of what it's supposed to look like on a mobile device. And there are, of course, other scenarios, right? Suspected spam, there's a verified caller, there's a few others in the combinations. Another specification that was recently put together was defining the API that's used to pass information to the authenticator and return the information back to the application. And this is a RESTful API. It's a little different than the mechanism I showed you earlier. The mechanism I showed you a couple of slides back was actually done with SIP headers and IDs. And this is a RESTful API for accomplishing the same thing. Some applications, this is an easier method to use. And I think AT&T is using this as part of their mechanism. So they've standardized this API too. All right, so far, all we've talked about is pure IP calls. Unfortunately, part of the world has still got TDM, right? How do these guys that have TDM switches and TDM infrastructure deal with this? Well, we can do the same thing with some tweaks to the gateways, some media gateways. So in this case here, we're showing a TDM switch, and they may have different trunk groups that they can send a call, either their ATISation, either A, B, or C. They can drop it into the gateway. The gateway can do the same mechanism we talked about earlier. Send a call over to the authentication cloud platform, get a response, pack the header onto the SIP call, and then drop it into an IP network, and it traverses the IP network. It could land on another IP-based service provider, or it could land on another TDM environment where it does the same thing. The only difference is when it gets to the TDM switch, how do they display that information? And there's actually some specification in the ATIS about putting like the word spam : at the front of the display name and the caller ID, or to put an asterisk, meaning I'm not sure whether or not this is a proper caller ID. So there is a mechanism in the TDM world to not only collect information about the originating calls and then deliver it to the consumer at the far end. Okay, so a lot of pieces and moving parts on this, but there's a lot of benefits that come out of it, right? First of all, once it gets widely adopted, stir shaking will make people begin to trust the telephone numbers that they're receiving on their devices, right? Once it starts to get deployed, and you've seen the beginnings of it. I know I'm a Verizon subscriber. I still have a home phone. It's basically free, comes with a cable service. So we've kept it, And now I can see on the display between the normal robo screening that happens and the calls that do come through, I can see that there is some information on the caller ID to know whether or not it's fake or not. And once people trust them, they're more likely to answer signed calls, right? If you see the call's been verified, you're more likely to answer it versus a call that's a potential spam or unsigned. It'll improve call completion rates and hopefully reduce the being bugged by robocalls, reduce that churn that's happening for it. But one of the problems with this again is the originating service provider and the terminating service provider both have to do this. And it's kind of a little you first, no you first, no you first, no you first, right? That happens when you have those situations. What's happening in the Canadian market and what's happening with Verizon and a couple of the US based operators is a huge push. What's going to happen invariably is Verizon will say, I'm going to start putting these headers on the beginning of my calls, or when calls come to Verizon, I'm going to start displaying them whether or not they're signed. And if your calls from another service provider are not signed when they show up in Verizon's network, Verizon will put a question mark in the front of or say it's potentially spam or it's not signed. So your calls will be at a disadvantage. And then contact centers will say, well, wait a second here. I don't want to use a service provider who's at a disadvantage. I want to go to a service provider who is signing these calls for me. So there's going to be a little bit of a tipping point that eventually all service providers are going to want to do this, and it's coming very soon. It's coming within the next year or two is our expectation because Verizon and some of the other big service providers are doing this. So a couple issues to consider if you're going to head down this path. One of them is about how do we code or the attestation of the the calls, right? The A, B, and C we talked about. There are a couple of weird scenarios where you've offered a trunk group to as a wholesale operator, you've offered a trunk group to a retail provider. You don't necessarily know where those calls are coming from, and you need to get that provider to start securing their network. What about when a signed call fails its verification at the recipient end? What do I display? And for example, in a contact center application, how do I, if those kinds of calls come in, what do I do with them? Policy options, the fail verification, and of course the certificate repository is a little bit of a sticking point because right now there's a handful of people that are saying I'll do it, but it's not quite gotten to critical mass yet. So there's a few technical issues still. The authentication function, how do they attach it to your network, which is we talked about, the SBC or the media gateway is likely going to need to be revised or updated so it can support this. There are a handful of them. I showed you, us from Telco Bridges, both our session border controller and our media gateways now support this. And for us, it was fairly straightforward. It's a script that we had to put, a routing script in the two. What kind of options you have for a verification function, right? So do you go to a service provider? Do you try to host this yourself? Which service provider do you get this from? What does it cost you, right? Some of those decisions. And of course, what about those big, huge SIP headers? Because now all of a sudden you've got these giant, huge SIP headers. And there will be some soft switches and others that won't know what to do with such a giant SIP header. Of course, how do you, are you going to deliver those tokens? And what happens if you don't, right? If you don't put those tokens at the front. So, and the key thing is between TransNexus and Telco Bridges, we can help you with these issues and obviously like to work with folks on it and offer some advice. In a nutshell, what TransNexus is doing is they've put together the software for the service providers that can do that verification process we talked about up front. If a service provider wants to have their headers signed, they can send the call over to TransNexus and they can sign it and return it. And of course, what we've been doing is, again, the software and our media gateways and session border controllers to handle that. And we've been working closely with TransNexus on this. So one last thing, there's a couple places where you can learn more about this. We've been working with TransNexus on a Discover Shaken workshop, and this is a kind of a deep dive on a service provider specific situation because every service provider is a little different. we can sit and work with them on developing a program that fits their particular need, maybe some software updates that are necessary, and some customization. And that's to learn more is at discovershaken.com. So is a resource. I'd recommend you going to that. And last, of course, as part of the solution is our free SBC from Telco Bridges, and we're here in the booth at booth 301. And the free SBC is a relatively new entry to the SBC market, but it's a full-featured session border controller that's sold as a software in a freemium model. It's actually a free version of it and paid versions. Yeah, question?
One of the functions that's pretty common in a typical UC application is find me, follow me, where a call comes in, hits a desk, and that original caller's information bounces out to the subscriber, and it's their caller ID. How would that work in this scenario?
Right. Good question. I'm going to repeat it for the video. In a lot of UC applications, there's find me, follow me. If the call shows up to a particular number and the individual's not available at that, and of course it tries to hunt them down a second number. That's actually part of the application at the terminating, either the terminating service provider or the terminating enterprises platform. That call at that point will have already been decided whether or not it's a trusted originating call. So in the various places that the individual is tracked down, we'll get the same indication of either it's a trusted call or it's a potential spam or it's potentially fraudulent. So it's really up to that UC application to decide to do something else than that, right? If a call is not trusted, when it gets to the UC application, it could say, I'm not going to send this to the find me, follow me because it's not signed. Or it could just say, I'm going to start calling.
That's not actually, it's more about, let's say Verizon is the cell phone provider for the roaming user.
Okay.
It's Verizon receiving that call with the caller ID that does not belong to the corporation that sent it because it was passed through.
Right.
That's the problem.
Yeah, okay, so, all right, so it's find me, follow me on cell phones is a scenario, right? Again, it's up to Verizon to decide before they start hunting, looking for the person, whether or not they even want to pass the call if it's not signed, right? So maybe 5 years down the road when 90% of the service providers are signing their calls, Verizon will say, if it's not signed, I'm not even going to send it to the consumer. I'm just going to throw it into a voicemail box. Or they could say, I'm going to play, an air tone back to the originating service provider. But it's up to Verizon's soft switch to make a decision about what am I going to do with that call. Do I actually, do I deliver it as a spam call to the consumer, and in that follow me situation deliver the same, or do I somehow indicate it differently? And it'd be that soft switch that makes that decision, that class 5 switch at the provider. And honestly, they're probably going to each do a little something different, right? Okay, but that's a good question. Right, so that's the trick. Was we talked about the originating call, and the origination is that before you drop the call in the public network, you need to go to one of these authentication services. Is probably the fastest and easiest way to do it.
So you can just pass the token along to Verizon?
Yes. Yep. It's in the SIP invite, and it just is part of the header, and off it goes. Once it's been signed and the token's on there, it'll pass through their network untouched. Okay. All right, let's see. A couple places to learn some more. Next week at the Illinois Institute of Technology in Chicago, Eric Berger, who's the CTO at the Federal Communications, is giving a talk on the comprehensive approach to illegal robocalls, which is basically, he'll go into a little bit more of the political side and some technical side of the Stir Shaken initiative and probably share some other thoughts. They usually post their proceedings live on the web. So if you search for the Illinois Institute of Technology Real-Time Communications event, which is a mouthful, either attend it in Chicago, and I think it's like $100 to attend it, or you can watch it online, live stream it. In December, the SIP-NOC event has a whole dedicated track specifically on this, where they go into much more detail on this in Herndon, Virginia. And that's another good place to learn more about that. Along with a couple other resources. We've got our blog at blog.telcobridges.com, and also on on our freesbc.com website, on our video channel, is a recording of the webinar that we did a couple of months ago. So with that, I guess I'll just open up for general Q&A. Any others?